problem 47, right? Let's do Monday. So I think Desmos is definitely going to help you on this one before you even go try it. Because it looks like you're gonna have two different sliders, right? It looks like you're gonna have a slider for A and a slider for C. So we have a two-piece function. Oh, yeah. And the one piece is x cubed minus a cubed over x minus a, and that I'm going to use that if x is not a. Oh, I know what it is. I know what it is. We had to let x be a. And then I use just the number c if x is a. So at one particular point, this function's got a hole in it, and I want to patch the hole with that height of c. Is that making sense? Dogum, you got your mask? I'm sorry, I'm telling you, October, first week of October, they're going to tell us optional. I would say if you had a cough on a particular day or sniffles, you come in and wear the mask just to help the rest of us, right? But otherwise, you're feeling good, right? Once they say it's optional, then it's optional. I mean, how many years have we been wearing this now? Almost 3 years already, right? Or there was some debate the first 6 months or whatever. But I remember I went to Beijing, I think in 97 or something, 98, 1999. And they burn in Beijing, in China, they burn coal to cook and to heat, and it's just thick air. Everybody there is wearing a mask. Anyway, I mean, this is a long time ago, and so we just got to get used to it, I guess. So on this one, what's the main thing about this continuity is I got to get these things to match up, right? So I really am looking at a limit at A only, right? There's kind of not, remember the other one was like less than 2 or greater than equal to 2. So we're definitely thinking about left and right of here. So on this one, we're just really looking at the two limits. The limit as x goes to a of c had better be equal to the limit as x goes to a of x cubed minus a cubed over x minus a. And you should recognize that one because it's been on a couple of quizzes already, right? We definitely have a hole there at a. And we want the height to be AC. We want the height, there's a hole, right? But at x equals a, but it's really, we want to patch it with xc. Does that make sense? Sorry, AC, right? I want the x value to be a. Yes, that's what's telling me here. X value is a. And I want the height to be c. But it's got to be for this other function. Yes, you with me? Good, so star here on the right is what? X minus a times x squared plus ax plus a squared, right? Maybe we have that memorized already now. So that's kind of nice because we get x squared plus ax plus a squared. And where is x going to in that limit? Where's x going to? A. So all I got to do is plug in x as a, and then I've got my solution. And I think I kind of see it right away, right? Don't I get a squared plus a times a plus a squared? That's 3a squared. Abigail, that makes more sense to you, right? I'm assuming everyone else didn't even start it yet, so it might not make sense to anybody else yet. But when you start doing that problem, remember to think about where is x moving to, right? Yes? Morning. You know that feeling when you forgot your phone somewhere? You don't have it on you. You're like, oh my God, where? I've got that feeling right now. I know where it is, but so continuity is kind of weird. Let's do another continuity problem. So I'm going to give you a three-piece suit here, a three-piece function. And I'm going to say it's a negative 1 if x is less than 1. It's an ax plus b if my x values are between 1 and 3. And it's a positive 1 if x is greater than 3. Now, we showed how to graph this on Desmos, but this one is pretty damn easy, right? But I will check it on Desmos today, okay? And when I do Desmos, make sure you're doing Desmos, right? Because for the quiz today, Desmos has to be used on the school computer. So this one's pretty easy to graph. I know my x values of interest are 1 and 3. If I'm left of 1, my height should be negative 1. If I'm right of 3, my height should be, positive 1. Right? So we agree with that piece? The furthest left part of the function is just the horizontal line at negative 1, right? And it's why for the circle here not filled in because it's not equal to 1. At 3, bigger than 3, it's just the horizontal line at 1. And again, why is it in the circle? Right? And then what's our goal? To do what with the middle function? Connect them. That's it. So I'm kind of visualizing my ax plus b. The piece I want for that middle function is right there. Is that making sense? Nice. So, and again on Desmos, I'm going to have a and b as a slider, and that segment or that line you can see it can move anywhere, right? Yeah, so you should be good at graphing functions, but if you can't graph a function, what do? Put it in Desmos. Put it in your calculator, right? You remember graphing lines, we would always pick 2 points, right? So what 2 points do I have of interest here? X is what and X is what? Yeah, 1, and of course the height there is negative 1, and the other one is 3 and comma 1. Well, I got 2 points. That's all I need for a line, right? So what's my slope of my line? 1 minus a negative 1. Make sure you're with me here. All over 3 minus 1. So I get 2 over 2. I get 1. So there's the slope of my middle function. I still need to find the b value, right? So y minus 1 equals 1 times x minus 3. I'm just picking the point that I feel like it's easier for me to deal with. So I pick 3 comma 1. And I get y equals x minus 2. So that's that middle function. Is that making sense? So conclusion, A equal to 1 and B equal to -2 make f of x continuous. Right? The question was find A and B so that I get a continuous function, right? How are we doing here? Are we okay? Question, yeah? If I don't get a 0, well, so remember, we're trying to get heights to match up. So the height could be 0. There's nothing wrong with getting a 0, right? But we're careful about getting a 0. That's the one we're trouble with. Exactly. We know there's going to be some kind of discontinuity at a 0 over 0 because there's an actual hole in the tracks of the roller coaster, right? So let's look at this one on Desmos, right? Make sure you're doing this with me on Desmos. So we have 3 pieces, right? So I had y equal to -1 for a curly bracket x less than 1. X less than 1. I know there's a hole at the end of that line, right? I know there's a hole at 1, -1. And I can do that on Desmos with this little kind of a gearbox. Click on the point and then make it an empty point. I don't have to do that. I'm just kind of showing you the tricks that are there, right? My middle function is y equals ax plus b. And we're adding those as sliders, but we want to restrict that value between 1 less than or equal to x less than or equal to 3. And you see here, before I even mess with anything, I can change the slope, and it looks like I definitely have to change the b value to get that thing down there to match up, right? Is that making sense? And I could put the points on the end of that green segment, but it's a little bit, I'm wasting time doing those kind of details. You're wasting time when you change your font 7 times, you change your margin 6 times, right? So don't do that stuff. But I know I have to connect the other height at 1, right? That's the other function. Yes, you with me? So back to here, my Desmos piece. Let me put this last function in again. What was it? Y equals 1, right? Oops. Y equals 1. And I want to restrict that with the curly bracket for x greater than 3, right? So now you can really see where I'm trying to connect, right? Making sense, everybody? Yeah? Now we figured out, so it's nice, we figured out that A was 1 and B was -2, right? Boom. Not so easy to do on the TI-8384, which is why I'm very happy we're in the computer room, because this really helps you see whether you got it right or not. And again, Sheila was saying the other day, well, are we doing the Desmos to get the calculus, or are we doing the calculus to get the Desmos? And it's kind of both. I'm trying to have you learn the calculus, but be able to check it, right? So that you're trusting the calculus. It's really what I want you to do, right? Be able to say, oh, I know how to get that highest point. I know how to get the slope, et cetera, et cetera. How are we doing? Nice. Here we go. New stuff. We're talking today about L'Hopital's rule. This is from chapter 4. So I do this section from chapter 4 for the chapter 1 test, chapter 2 test. And it's very easy. And you're going to say to me, well, why didn't you teach it to me at the beginning? And that's the deep thought I want you to have. Why didn't I just teach you this right away? So let's take a look at, Abigail, can I borrow that chapter, that page again? Mine? You got some homework due Monday. From 2.3, number 23. And some of you have been hating the factoring. Anybody besides me hating the factoring? This will mean you never have to factor again unless I ask you to, and I will. So, but this is called L'Hopital's rule. So this dude was some French like part-time mathematician. And supposedly he would hire real mathematicians to prove things, and then he would buy them from them to get his name out there as someone who's a published mathematician. I guess there's some sick math people too. So it says that if f of c equals g of c equals 0, and the limit as x goes to c of f of x over g of x, then is equal to the limit as x goes to c of f prime of x over g prime of x. So it's saying if I get what? When I'm doing my limit and I get what? What do I get? 0 over 0. If I get 0 over 0, I can simply take the derivative of the top, the numerator, and take the derivative of the denominator, and then redo my limit. In fact, if I keep getting 0 over 0, I do it over, do it over, do it over. Okay? So let's take a look at our first homework problem for Monday. And I'll prove this to you today. It says, I want to do the limit as t goes to 1 of t to the 4th minus 1 over t cubed minus 1. Now, that's one you should definitely be able to factor. But we're gonna see that L'Hopital's rule works for this. Did anybody do this one yet? What did we get as an answer? Yeah, 4/3. Yep. And remember, you're checking your work, right? Don't turn in a problem that's wrong to me. Turn in one that you've checked and you know it's right. So we should get 4/3 here. But let's look at L'Hopital's, right? So what happens when I plug t as 1? Upstairs I get 0, downstairs I get 0. So I want to take my numerator and get the derivative of that, and then my denominator and get the derivative of that, and then reevaluate my limit. All of these derivatives you're doing, I want shortcuts. I don't want you doing the limit process. Does that make sense? Don't do that f of x plus h minus f of x over h for this. Just take shortcuts. So as we move into chapter 3, we're only going to do shortcuts. Okay? So what do I get for the upstairs derivative? 4t what? Cubed minus what? Good. I wouldn't even write it personally, minus 0, I wouldn't write it, but I'm just trying to really emphasize that we're doing derivatives there. And what do I get downstairs? 3t squared minus 0, right? So now reevaluate the limit. Plug in what number? So 4 times 1 cubed over 3 times 1 squared is 4/3. Done. All right, get a little pissed off at me right now. Get mad. What's that? Derivative of a constant. Derivative of the line y equals -1. So it's a horizontal line, so the derivative is 0. Right? Yes, you with me? So why are you mad at me? It should be. I always got mad. You have to blame it on somebody. It's dangerous when we blame things on ourselves. Believe me, I did a whole life of that. You're going to blame it on me now. Why didn't you teach me this? Well, why didn't I? Yeah, we had to go through all this limit process to realize how to take a derivative, right? So I couldn't teach you derivatives unless I taught you limits first. So, but now that I have derivatives, I'm going to be able to do them so much quicker. Anybody remember this one? The limit as x goes to 0 of sine of x over x. Does anybody remember that answer we had? 1. It was 1. But when I plug in, I get 0 over 0, right? So I'm going to show you another way. So you could use this prime notation to say take the derivative of the numerator, or I could just put a little hop here for L'Hopital's. I'll just do a little hop. And so I'm going to rewrite my limit now. What's the derivative of sine? Anybody know it? What? Cos? Yep, cos. And what's the derivative of x? 1. So do you see that I took the derivative of the top and I took the derivative of the denominator? And now I'm going to evaluate. What do I get? Cos of what? 0, which is? 1. L'Hopital's rule. $25 is tough to do with L'Hopital's. I'm going to look at 26. So this is from 2.3, number 26. It says the limit as x goes to 3 of 1 over x minus 1 over 3 over x minus 3. If I plug in 3 right away, again, I get 0 over 0, right? If I plug in 3 right away, I get 0 over 0. So I want to use L'Hopital's rule. I want to rewrite my limit, but I want to take the derivative of the numerator. I do that with a prime, and the derivative of the downstairs denominator with a prime. The downstairs is easy, isn't it? The derivative of the downstairs is easy, right? It's just 1. Yes, you agree? mx plus b, right? What's the slope there? 1, right? Upstairs is not so easy. Anybody have it memorized yet? Nice. You want to see that derivative? So just a quick side note, if y equals 1 over x, that's x to the minus 1. And by the power rule, that's negative 1 times x to the minus 1 minus 1, right? Subtract 1 from the exponent. So that's minus 1 x to the minus 2. So that's negative 1 over x squared. I can simplify this now or simplify it after I plug in the number, right? Because when I plug in the number, I definitely don't get 0 over 0, right? Or I could simplify it now, right? I could bring my negative out and then do the limit as x goes to 3 of 1 over x squared. Why does the negative come out? Why can the negative come out? Right, we had that one property that said a coefficient can move in or out of a limit. Remember, a limit is just the height of a function. So I could multiply the function first and then put the number in, or get the height first and then multiply, right? So I get what? Negative what? One over 3 squared, right? So much quicker, right? So L'Hopital's rule, let me prove it to you, okay? You don't have to write it, you're not responsible for the proof, but I want you at least listening and saying, yes, I agree, or wait a minute, what the hell are you doing? Okay? You don't have to write it, you don't have to memorize it. If you were a math major, yes. Maybe if you're going to outer space, we're going to work in that field, you probably have to do a lot of math proofs. So any kind of aerospace engineering, anything like that, you'll do a lot of math. You'll do all the math that Einstein did. So this is a proof of L'Hopital's. And you'll see it looks kind of like hospital. And there's a couple of spellings. It could be just HOP instead of HOSP, but who cares? The guy's dead anyway, right? So let f of c equal g of c equals 0, right? Let me get a 0 over 0, because that's what I want to happen, right? Show the limit as x goes to c of f of x over g of x is the same as the limit as x goes to c of f prime of x over g prime of x. Now, when I'm proving this, it doesn't say which side I have to start on, okay? In fact, that's something to think about if you have to show something is true and you try starting on one side and it's not working out for you, try the other side, right? So I'm gonna start on the right-hand side. And just look at what is the limit as x goes to c of f prime of x over g prime of x. Well, we know the definition of a limit, right? In fact, we have like 3 versions of it. We had the f of x plus h minus f of x over h, right? Or what could be the other one? What do I want there? M equals f of x minus, it's hard to see my scribble here, but that says f of c over x minus c. And of course, that's the limit as x goes to where? where am I interested in x going here in this box? Where am I interested in x going to? C, yeah. So the limit as x goes to c of f of x minus f of c over x minus c. And then downstairs, of course, it's the limit as x goes to c of g of x minus g of c over x minus c. We know when we're doing limits, we can let our limit go to the numerator, a limit go to a factor, a limit go to a denominator, right? The limits kind of distribute everywhere. So it looks just like I was a little bit zealous with all of my limits, right? So this limit here is the same as this limit here. So I don't need it. Again, this limit here is the same as this limit here. I don't need this limit. It's useless. It's redundant. Maybe I'm stuttering saying it twice or whatever. You know what I mean? So I'm really just looking at this as a single limit as x goes to c of f of x minus f of c over x minus c, right? I'm saying I don't need to write all those limits, right? I know x is going to c. But now I've got something I can manipulate, right? I'm going to do a keep change flip here. So I've got f of x minus f of c over x minus c times x minus c over the g of x minus g of c, right? Keep change flip, yes? Fraction divided by fraction. Yes. Where are you at? Yeah. So, yes, but I said you can write it, okay? I don't mind if you write it, but you don't need to. I want you to agree with me, David, and keep writing if you're copying. I want you to agree with me that this limit notation is redundant. I want x to go to c, and I want x to go to c for this. I want to say it twice. I want x to go to c and x to go to c for this. So I don't say it twice, I say it once. I know x is going to c for everything here. But then I see that I can manipulate this and something will cancel, right? You see that the x minus c's will cancel. So I did my keep change flip just to show you that they're going to cancel. But
yeah, so the f and then f of x minus f of c, that's the same thing as that's another forward.
exactly. Secant slope. And as x goes to c, I get the tangent slope. I get the derivative. Yeah. Right, as the x moves, right, as on my graph, as x moves to c, right, I'm going to get that tangent line. And the derivative is telling me the slope of that tangent line. All right, well, some things cancel here, but I know something already. The limit as x goes to c now of f of x minus f of c. What do I know about f of c? What do I know about f of c and g of c? Remember, I originally said I have to get what? 0 over 0. F of c is 0, g of z is 0. So look what I get. I get the limit of f of x over g of x. That's it. That's the proof. I started with the limits of the derivatives, and then I ended up showing it's the same as the limit without the derivative. So there is some WebAssign homework with L'Hopital's. I don't think that's horrible for you to do. Let's do one more. This is number 30 in section 2.3. So I've got the limit as x goes to 16 of 4 minus square root of x over 16x minus x squared. So first of all, we're going to verify that we get 0 over 0. Right? True? 0 over 0, yes? Nice. So we're gonna move to L'Hopital's here. So your first question on the chapter 2 test is, here's a function, here's a limit, find me the limit algebraically, then verify using L'Hopital. 10 minutes to do that question, right? So, and then of course, you're going to also check it numerically or graphically on Desmos. And in case you got 2 different answers, and then you're going to know which answer is correct. You with me? So you know you did it on Desmos, you know you got the right answer, and maybe your L'Hopital's answer matched. That means you got your algebraic one over, do that one over. You could look to see if you can see the mistake, but most likely you won't. Brand new piece of paper, right? Yeah, quickly. And then redoing the limit. The deep thought is, why? Well, I proved it, but think about what's actually happening, right? So we're going to redo this limit, but by taking a derivative of the numerator and a derivative of the denominator. The denominator's easy here, right? Now you're copying this again, so don't let me go too fast, okay? So that denominator is pretty easy here, right? Do you agree? What's my derivative downstairs? 16 minus 2x. I'm already seeing if I plug 16 in there, I don't get a 0, so I'm, right? What about upstairs? Zero minus 1 over 2 square root of x, yeah. A derivative of 4, right? Yeah, so if y equals c, right, y prime is 0. Anytime I get a constant, it's a horizontal line, and we know the slope of a horizontal line is 0. So remember what a derivative is, it's the slope at any point. So no matter where I am on that line, I have a slope of 0. I can simplify it first. I tend to simplify it, but you don't really have to. We can just plug in, and that's what I'm going to do. So I get negative 1 over 2 square roots of 16 over 16 minus 2 times 16. So I get negative 1 over 2 times 4 over what? Negative 16. I get double negatives cancel, right? 1 over 8 times, divided by 16, 128. Yeah. How we doing? We okay? Let me look at section 4.5 real quick. So where am I going? WebAssign. Everybody's settled in with the book? Everything's okay? Dealer with, did you get a deal? Did you get that deal done? Oh, sweet. Buy yourself something. She had paid the full price before we got the thing fixed to 55, and then she got her money back. So make sure if you ended up paying the full price, you get your money back, okay? I want to look at the book. So when you open the book like this, in the top left corner is the index, right? And then I'm opening up chapter 4, and there's indeterminate forms and L'Hopital's rule. You'll visit this again in Calc 2, okay? So we have a couple of independent intermediate. We have 0 over 0 we're dealing with this semester. Infinity over infinity, we also use L'Hopital's. And infinity minus infinity, that's you're going to do in Calc 2. And what's the other one? Oh, infinity raised to the 0 and 0 raised to the infinity. There's all these weird forms that sometimes they give you one number or another. But the last few that I talked about, you'll deal with in Calc 2. So for Calc 1, the problems I like here, I just want to give you a list of numbers, that's all. Come on. Why does nothing work? So the problems I like in 4, 5, of course there's WebAssign problems, that's enough. But I certainly like (1 to 22), 1 to 21. I'm still working on getting you odd solutions. But of course you know how to check this limit and then see if your L'Hopital's rule works the same way. There's a couple in there that are pretty tough. 16 is tough. 15 you don't know how to do yet. If I look at the WebAssign there, first one's easy, second one's easy. You need to know the shortcuts, right? Derivative of cosine, derivative of this numerator is negative sign. Yeah, negative. This one you can't do. Don't do number 3. You'll be able to do it soon, not until we do the chain rule. So the first and second one there is good to do. Nice. All right, it's Friday. Guess what time it is? Quiz time.